What's up, YouTube? Today we're going to be looking at the Decorator Design Pattern. It's a simple pattern, but it also gets confused and as well as misused or not used for the right reasons. And one of the reasons is people are always using sort of toy applications or toy examples to explain and or remember them by. And I feel that's where the problem starts. So today we're going to be looking at some real world examples of the decorator pattern or usage of the decorator pattern. Hopefully that'll give you a better understanding of what it is and when to use it and how to implement it. So as you can see on the screen here, it says attach additional responsibilities to an object dynamically. So essentially what it's saying is at runtime. You don't have to do it at runtime, but typically it's happening after the fact. That could mean that you've already got code that attaches the additional responsibility after the fact. It's not really part of the class or part of the object. But dynamically essentially means at runtime, but it could also be such that you've already written the code to attach that additional responsibility on top of the object. Decorators provide a flexible alternative to subclassing for extending functionality. So I think the explanation, the definition, if you will, here is fairly clear. There's no real confusion, unlike the other pattern that they have in the book. But I think what needs to be explained here, first of all, is subclassing is a problem. Meaning, as they say in the same book, they say prefer composition over inheritance. So that's a very valid statement. In fact, as you get more and more experience with object-oriented programming, in my case, I don't use inheritance at all. There are two forms of inheritance. There's inheritance for the sake of extension or for the sake of inheriting existing functionality, typically from an ancestor class, and then adding on to that functionality or extending. And then there's inheritance for the sake of polymorphism, where there's no extension. It's change of behavior without any extension, because you need to be able to treat classes in a uniform fashion or subclasses of a certain base class in a uniform fashion. The only way you can do that is if you don't extend. So using inheritance for the sake of extension does start to get you into sort of a bind, if you will, where one of the system gets very unwieldy to understand, and two, sometimes you need to, if you got like multiple trees or branches going from the main ancestor, then you need some functionality here, but that's also over here, and you don't know quite how to get there. So composition is a better way. Typically, if it's just like one level deep, it's sort of fine when you're inheriting from an ancestor class. So the decorator pattern is in some ways saying there are times, not all the time, but there are times when maybe you want to think about using a decorator to extend functionality rather than inheritance. So a decorator is something that decorates, and that's a key thing to keep in mind. It is not self-sufficient by itself. I'm a human, I'm fully functional as a human. Well, one would think I'm fully functional. And the clothes decorate me. The clothes don't become me. The clothes don't exist to have any purpose by themselves unless they are on top of me, like they are decorating me, right? So I've seen many examples in blogs and on videos on YouTube, and people, when I talk to them, they give these stupid examples that don't make sense at all. And I don't know if they don't understand it, or they're trying to keep it so simple that they're kind of breaking the basic idea. The short of it is this: decorators decorate only. They do not do the work. And I'll give you an example. For example, there's the famous, I think, example on the internet at least seems to be coffee, right? And you have an espresso coffee or a filter coffee. So the notion of being an espresso or a filter coffee is not a decorator. The coffee has to be in and of itself a coffee, right? Because the process of making an espresso versus a filter coffee is completely different. You can't say that's a decoration. So some people get it right, Some people say these are two different classes that can then be decorated with things like creamers and sugar and whatever else, but some people actually confuse that and say the decorator, the filter, and the espresso itself is a decoration. Or they'll use the notion of a vehicle and where the engine is a decoration. The choice of the engine is a decoration. No, it's not, because the vehicle by itself does not function without an engine. Now you could say the paint is a decoration, the body or the shape of the body is a decoration. But the vehicle has to be fully functional, and that's something you have to sort of keep in mind. When you're decorating something, the thing you're decorating is fully functional. You're simply adding on a decoration on top of that. And if you see that there's a need you have that can be supported, where you're simply decorating something on top of the thing you're trying to decorate, then you could potentially use the decorator pattern. But don't use the decorator pattern by way of composition, where you could actually be composing. A vehicle is made up of an engine, and then you can choose which engine you want. That is not a decoration, that's a composition. I hope that's making sense. So attach additional responsibilities to an object dynamically. Decorators provide a flexible alternative to subclassing for extending functionality. So you're trying to extend functionality, but not trying to provide the functionality, if you will. Right? It's not like a decorator is providing the functionality. It's extending a pre-existing self-sufficient functionality. It's a simple pattern in that there are just two participants. There's a component, which is the thing that you're trying to decorate, and then there are decorators. So there's a component. There could be one or more concrete components, like the case of, maybe there's multiple different vehicles that descend from a base class, but there are concrete vehicles, and then each one can get a different paint color, can get a different body, can get different tires, and maybe you can use those as decorators. I'm not saying that's like a good design necessarily, but just to give an idea, there's concrete classes, and there could be many, and then there are decorators, and there could be many of those. So there's just two. Now the confusing part is, as you can see here in the UML diagram, now just for those to remind some of you, this arrow in UML indicates inheritance, and this arrow in UML indicates aggregation. Right? So this is the base class, and it's got some operations, and then the concrete component descends from or inherits from the component. So these are all descendants of component, and they therefore also inherit the methods that are there in the component. The decorator is nothing but a descendant of component. So it actually comes from the same hierarchy. It descends from the component, but the thing that distinguishes the decorator from the other components is the fact that this decorator also aggregates a reference to a base class. And this becomes important because that's how it decorates. And it'll become clear once we see some examples. It's not required that there's a base class for decorators, but essentially that's how you would design a system, especially if it's a large system, to warrant this, where you might say, okay, this decorator has a constructor that takes in a reference to a base class of its own family, and therefore anything that descends from it will automatically be forced into that whole thing of having to satisfy that constructor, right? So the other components are simply the concrete implementations of the component, and these are the components that you might want to then decorate. Whereas the ones in the orange is the hierarchy of decorators. They are not the ones that actually do the functionality, but you're decorating the other classes, these classes here, component 1 and component 2, with these decorators, potentially one or more. And that's another thing about the decorators, is they can be kind of chained, and I'll try and explain that to you in the next slide. So in the next slide, this is in fact the sort of object model, if you will, from in .NET itself. So in .NET, we have a stream class, which is the base stream class, and there are a few descendants: the memory stream, the file stream, and the network stream. These are concrete implementations that descend from stream, and you can tell from their name, the memory stream works with bytes in memory. The file stream is able to read and write bytes to a file system on the hard drive. The network stream is able to send bytes across the wire, TCP typically, but it could be UDP or whatever other network that you're supporting, protocol you're supporting. The network stream can support writing out to sockets and things of that nature. These are full-blown implementations, fully functional implementations. We also have, descending from the same stream base class, the gzip stream, the buffered stream, and the crypto stream. Now these decorators, and the reason they're orange is so that they're decorating, you can see that they each aggregate a reference to a base class. By base class, I mean it could be any one of the descendants from the base class. What that implies is that typically, and this is how most decorators are done, but it's not necessary you do it that way, but I would always design my decorators in this fashion, which is the constructor itself, the constructor of these decorators themselves ask for, and these classes cannot be constructed without a reference to the base class, so that you can't have a decorator that doesn't have a reference to a base class, because what is it decorating otherwise? So the reference that you provided in the constructor is the thing it is decorating. And this might become more clear once you see some code. And the idea here is that the gzip stream class is not necessarily a stream. It's not functioning as, it's not a fully functional stream, but what it can do, given its own aggregate, the thing that is, the reference got a reference to, it can add value to that stream. So if I give it a memory stream, the gzip stream can compress that data in using the gzip algorithm. And every time you write some data to the memory stream, the gzip stream is in turn taking that data and compressing it. Same goes with the file stream. If the gzip stream was given a reference to a file stream in its constructor, then the gzip stream can effectively compress the data on the hard drive in its own algorithm, right? The same with the buffer stream, is able to buffer the data so you can write faster. It's not constantly trying to write and to the hard drive, which could end up being a bit slow. So the buffer streams are used when you want to disconnect the actual writing out to, let's say, the network or the file system, and just buffer that data in memory before you start sending the data out. The crypto stream is able to encrypt and decrypt data that's being written to a stream. Now you can imagine you could have a stream, let's say a network stream. So you're sending data across the network that is being encrypted and also compressed. Right now you could decide whether should I first compress the stream and then encrypt it, or should I encrypt it first and then compress it. Right? That could be depending on what's going on, but typically you should compress and then encrypt, because encryption bloats the size quite a bit. So if you compress the data first and then you encrypt it, you have a smaller file size or smaller bytes being sent across the wire. Either way, all I'm trying to get across to you is that decorators can be chained, right? So this one decorator can take another decorator, and so on. So they get like a chain of decorators. And eventually there's some decorator that aggregates the real class that's the concrete version of that class. So like a file stream or memory stream or network stream in this case. So there's .NET examples of this. We'll look at that example just briefly so you get a sense of what I'm saying there. And as part of our the video today, I'll be also discussing two other real-world examples. One is logging and timing decorators, and the other one is the image watermark decorator, which is probably the more fun one. So let's take a look at the compression and encryption decorator. I'll just show you the compression one, and you can imagine the encryption one as well. Okay? So let's say I have a file stream. Add some location, and I want to write or create a new, and then I want to write. Right, now this so for the first bit I'll just write this to some file called data.txt. Right? And what am I writing? So what I'm going to write here is a bunch of bytes. So by the way, you should know that the compression is gzip, so we can't use like WinZip or the default zipping unzipping of the Windows platform. You have to use a tool called 7-zip or something of that nature that supports that. So the 7-zip is an open source product you can just download. I think I have it on this machine. Okay, so once I got this, I want to write to this file stream. And this write will take a buffer starting from position offset 0 up to buffer.length bytes, right? And now typically in a real world system we would flush this as well, just to make sure that the things are written before the disposing of it, but it'll happen anyways before disposing. Okay, now if I were to run this application, we should see that there's a text file created in this location of the here. So you can open this text file and it's got this hello world in there, right? All right, so now let's encrypt it. So the way the encryption will work is, remember that the gzip stream is nothing but a descendant of the file stream itself. You can see the file stream here descends from stream, right? And if I were to now use the gzip stream, I think that's the last name, yeah. You can see that it takes a stream as in the constructor. So it's asking for a stream, right? So this is sort of the mark of a decorator. It descends from the same family and it's asking for one of its own ancestors. So it's going to decorate the stream you give it. In this case, you want to give it the file stream, so it can then compress that file stream into a zip file. So here I'll pass it file stream. And the second compression level, isn't there another constructor? Compression mode. Compress. Right. So, and then I would also want to write, and I'll write to this instead of that. So essentially I'll copy, or I'll just honestly just change this out to be gzip stream, and then I'll do the flush on the gzip stream. And I should probably put this in a using as well. going to change the name of this file to zip just so that it doesn't become, I don't have to change it otherwise manually. So all we've done is we've created a gzip stream that's a decorator. We give it that file stream that we want it to decorate. The file stream is fully capable in and of itself. Keep in mind that the decorator is not doing the work of the file stream. The file stream is doing the work. Internally, the decorator is calling the file stream to do the parts that it needs to do. And then after that, it does the parts that it's supposed to do. Right? So that's how the decorators work, which is why I say the decorators have to be decorating something that's fully functional and can stand by itself. In this case, the file stream can stand by itself. So now the same file, if I look at this, this was the previous one. This is the zip one. Now here I'll have to, hopefully I got, yes I do have, I'm not actually very familiar with 7-zip. Oh gosh, I don't know what it's doing. Extract all. Open archive. Let me just open it. Alright, so maybe I need to extract this somewhere. Okay, let's extract it there. So it's here. I don't know what is this, a text file or what? Let's see. If it's extracted, it should be a text file, or is it the actual? Yeah, so there you go. So the gzip stream took the file stream, let the file stream do its part, which is writing out to a file stream the data, and then it took that file and it compressed it. Right? So that's how the decorators work. So that's the simple example of using the built-in classes in .NET, the stream classes that I have the whole decorator pattern in there. You could take that compressed stream and then further decorate it with a encryption algorithm and so on. Right? So this is how the file stream stuff works. Okay, now moving on to the second example, which is more real world. So I'm going to start with, if you have not seen my strategy design pattern video, I'm using the same code base. I'll modify it a little bit and we'll take it from there, right? So I'm not going to explain the strategy part, and it's not required to use the decorator with the strategy. It's just that I have a bunch of code here, so I'm just going to use that because I'm using the strategy design pattern project. It's just I've already got all the code here, but the strategy design pattern and the decorator don't have to go hand in hand. It just happens that I have this code, and I think it's a good bunch of code that will help you understand the decorator pattern. All right. So in the strategy design pattern project here, we have this whole sorting thing going on. So we have a sorting strategy base, and then we have either heap sort or insertion sort or quick sort options. And so we'll use this to for one of the examples of decorator. So let's say for some reason you decide, I want to log, let's say, or I want to time how much time something takes. In this case, the sorting aspect. So how do you pull that off? Now, of course, there's many ways to pull this off. This is one example of it in the real world. In production scenarios, this is quite frequent when you want to do, let's say, logging or timing that's temporary. It's not something you need to leave in production. It's something you're just trying to do maybe in lower environments where you're not yet in production. You're in like a staging or whatever other environment you have before production, and you're just trying to get sense of, it's a temporary thing, right? Where you would decorate. Now you could also use this in production as a way of a decorator, but I don't necessarily see the value of that if that is a actual requirement in the system. All right. But again, it's an example. That's not to say you shouldn't use decorators in a system. Remember, decorators add on functionality dynamically, right? So the beauty of the decorators is that you can add on functionality dynamically, which means you can get this change in behavior by way of using different decorators at runtime. Right? So what I'm not showing you here in these examples so far is there's no runtime decision being made, but typically decorators are being used at runtime. Right? It's dynamic. You're adding on functionality dynamically. So if I go into, let me make that sorting project the starter project. And if I look at the context, number sorter context. So essentially what's happening here is no matter what the algorithm is being used, I want to be able to time and log, let's say. So let's just first do the timing and then we can do let's do the logging first and then let's do the timing later on. Or we can all do it together nonetheless. So the decorator is a descendant of the same component hierarchy. In this case, the component is the sorting strategies. So the decorator will also descend from the sorting strategy base, just like these other classes here, the sorting strategy insertion, sorting strategy heap, and sorting strategy quick. They're all descendants of sorting strategy base. So our decorator also needs to descend from sorting strategy base. So let's do that. So I'm going to create a new class here and I'm going to call it sorting strategy. I'm just going to call it decorator for now. You might have multiple decorators: sorting strategy, decorator logging, sorting strategy, decorator timing, and so on and so forth. But we just call it decorator for now. And this class descends from the base class, sorting strategy base. And then if it needs to implement stuff. Now remember, we need to define a constructor. It's not a requirement, but it's just good practice when you're working with decorators to show your intent. I don't know if you've seen probably see the title on the bottom there on the video itself. So this programming with intent. I'm a big fan of. It's something I've developed over the years, and I call it programming with intent. And if you haven't seen videos on my programming with intent, please take a look at that. But it's important to show your intent. It's important to show your intent for yourself, your current person, your future self, your teammates, and other people that might join the team in the future. What is the intention? In this case, I want this class to be a decorator. And I show my intent by saying, in the constructor, I need an instance of an ancestor, right? So I'm going to define the constructor to take a sorting strategy base, strategy, and I'll keep a reference to this class as a private member. And then I'll assign it. Okay. So now as soon as this class is constructed, I have an instance of the thing that does the real job. You need a reference to the thing that's actually doing the real work. This thing is just a decorator. And the reason it descends from the same hierarchy is so that you can treat this thing like that thing. Right? You can treat the decorator just like you would treat the actual thing. And so it's easy to swap out at runtime, if you will, dynamically. Now its implementation, as I said, it doesn't do the work itself. So it calls on the ancestor class that it's got. No, it's not the ancestor, but the reference to the actual class. Right? So it's going to call on the sorting strategy and say, you do the sort. I have no idea how to do the sort. You do the sort. Right? So it's going to call it. It's going to pass in whatever data. So at this point, it's forwarding the call on to the thing that actually does the work. Which is why the decorator itself is not doing the work. The decorator needs the class that actually gets the work done, because it doesn't know how to do it. It simply knows how to decorate. My clothes are not me. My clothes are not human. I'm a human. I'm fully functional, one would think, as a human. The clothes are simply decorating me. The clothes need me to fill out and look at the shape of a body. The clothes by themselves don't have that feature, right? Now, I think at this point, a lot of people say, oh, I get it. Exactly. Now, I can be doing something here before the work. I can be doing something here after the work being, in this case, sort. So if I wanted, I could be logging something, and then sort method done, right? What happened? Okay, so you could see that it's easy to log some, it needs to return this. Okay, so in this case, let's say sorted numbers, and then I can return sorted numbers. So this is typically how all decorators are implemented. They don't actually do the work themselves, so they do call to the class that they are decorating. They have to. But because they are calling that method of the class that they're decorating, they get a chance to do something before and or after that work has been done. So now we've just simply logged, let's say, but you also time, right? You could have the time here. So first, just let's see how this works. So we got a decorator so far, and it's simply doing the logging for now, right? And we say, okay, now what we go is we go back to the context. Oops. And in the context, we say, okay, we have an instance of a sorter, which is one of those base class descendants. Then here, we could say, let's just now say this is a new, the decorator class, the sorting strategy decorator, which we know needs an instance of the sorter in the constructor, right? And we can call the sort method on it. So we are calling the sort method on the decorator, by the way, here. And we're passing it the numbers, knowing that it's going to pass the numbers down to the actual class that does the work, and then it'll decorate the before and the after functionality. I think at this point, most people say, oh my God, this is like such a simple thing. Yes, the pattern is simple. The usage is complicated, meaning it's not complicated. The usage, like with everything else, if you use the wrong tool for the job, you just don't get a good job done. Like with everything else, if you use the wrong tool for the job, then the system just gets a mess, right? And because you've got a hammer in your hand now, don't go looking for the nails. I don't know if you've heard that phrase before. Once you have a hammer in your hand, you go looking for a nail. Everything looks like a nail, right? Don't go looking for the nail. Let the opportunity present itself to you. Having a set of tools in your toolbox is fantastic. You need as many tools as you can have in your toolbox. The trick is not having the tools. The trick is knowing which tool to use when. And that's where most people's kind of design breaks down or falls apart. They use the wrong tool for the job. Anyway, so here's the decorator. Now let's look at its usage. If I were to, I've forgotten what the program CS class is doing here. Okay, so it's calling on the numbers context, and the numbers context will randomly pick, not randomly, but it's got its own internal logic, so the call side can't control that. The call side simply calls sort, and we don't know which sorter is going to be used. But because we have sorted any sorter, it doesn't matter what the sorter is. We sorted every sorter. We've decorated any sorter. To us, it doesn't really matter. Right? Either way, no matter what the sorter is, this decorator will decorate any of those sorters or those instances. So on this end, we write the class, and then we come here and wait. So let's run this application and see what happens. So as you can see, it says sort method called, sort method done, and then this stuff here is actually been written out. Oops, didn't mean to do that. This stuff here is written out at the call side. So all that's happened by the sorters is that it's done the before and the after, and the rest of it is just part of the call side's code. So actually we logged, let's say we want to time it. So we'll go back to our decorator, and we'll change the code here. Instead of timing, or instead of just writing this method call, we'll have stopwatch. So now that we have a stopwatch, we start the timer, if you will. And when we finish, we stop the timer. And then instead of writing begin and end of the stuff, we'll just say time to sort. And we'll put this in milliseconds. So in this case, it'll be stopwatch.elapsed milliseconds. Okay, so now instead of logging it, we are simply just timing it. Now let's look at the output. So you can see here, oh, misspelling it. Okay, so it took 0 milliseconds. Of course, there's not enough data there. There's just so much data. Let's increase the size of our data here in our program CS. Let's say 0 to so many. I don't know, that'll cross the bound anyway, but there should be some milliseconds now. Yeah, so we can see now it took 67 milliseconds to do the sort. So you can add logging, timing, any behavior. It doesn't have to be logging and timing. That's sort of the more common use case for this. But you could embellish, you could decorate any pre-existing class that's doing the work just fine, but you want to do something in addition to what it's already doing. And at runtime, you could decide to do different things based on criteria, based on business rules, based on user input, what or how to decorate something, or to or not to decorate something. So in this case, I've used the strategy, but as I said, it's not really required. You don't want to get the strategy in the business of deciding what to decorate and what not to decorate. It just gets complicated. Okay, so that's one use case here. Let's move on to the third use case. I'm hoping this is like you're getting enlightened and you're getting excited about this. I certainly do when I do this stuff. Okay, the next case would be, or next thing would be to take an image and create a thumbnail of it. We already have the code, but we have the code, pseudocode that does that work. I'm going to implement that now. So the idea here I want to show you is you take an image, you can thumbnail it. Let's say you already have that feature, the ability to thumbnail. All right. Now you want to decorate that thumbnail with a watermark. So if you don't know what a watermark is, it's one of those sort of faded images, typically like copyright and other information on images, so you can copy, but it doesn't have to be faded or kind of slightly transparent. So you want to watermark it after the fact. In other words, the thumbnailer class, the image thumbnailer class will do the thumbnailing, and the decorator will decorate that thumbnail on top of that. So let's take a look at that. For that, I need to make my forms application the startup form application, and also the thumbnail is actually in here. So let's look at the context. So we have the media thumbnailer that can support, currently supports thumbnailer audio and a thumbnailer video. So 2 thumbnailers. These don't actually do anything, but let's just run the application so you can see what it's doing currently, the forms application. So if I pick audio, it produces an image. So this is a sort of a real image, if you will, and I'm just dropping it on the form here. And if I picked video, it would produce another image, and it just says that's the video versus that's the audio. So these are real images, but they're not really creating a thumbnail, or they're not extracting a thumbnail from an audio file or a video file. That's what they do currently. And we want to add on to this a image thumbnail. So let's look at the form CS and see what is it doing here. Okay, so we need to add one more in our drop down for image, and this will be image PNG. So got that sorted, and here it's going to call, okay, so we can use that image PNG here then. Just to match that. And then here our media thumbnailer will be an instance of, what do we have? So I actually implemented this class, so it saves us the time. So this class is essentially implementing the basic thumbnailing, and because I didn't have the functionality to provide it with the file name, and because I didn't have the ability to provide it with the file name, I've sort of hard-coded the file name here. This file actually exists. So let's take a look at this actual file name here. It'll be in the ref part of this projects folder. So there are two images. One is this image. Now this is a huge image in terms of file size. If you look at the size of this image, yeah, see, that's pretty massive. So what you're seeing is a sort of a smaller version. So it's massive, and we want a thumbnail of this image. And then while I'm here, let me also show you the watermark. You may not see the watermark clearly. It's weird to see this, but there's a watermark here, and you can see it's got some stuff with my name and intent. So basically it says this is my name, and this is in white, so you don't see it here. And it says programming with, and then you see the word intent, which is the noise. The others are all in white, so you don't see it. So we have these two images. That's the watermark, by the way. The other one is this one. So this thumbnailer is taking the image and it's going to create a thumbnail, and it's responding to the size we provided here. So it's basically going to create a thumbnail of width of 400. Actually ignores the 300 here because it needs to maintain the aspect ratio. So that's just going to use the 400 width. So now that we have that hooked in, I think we did. Or we need a break here. So we added the image to the drop down in the form. We've come in here and we've added the image, the thumbnailer, to the context. Let's run this app and make sure it actually works. So this still works. That still works. And now we have image here. Yep, that still works. So this is the actual size. So now this is just a width of 400. From that massive image, we actually have a thumbnail. So this part actually works, all right? Now, the thing is we want to decorate this. So let's say dynamically runtime, however you would decide that. So I want to be able to decorate any thumbnail that this thing creates with one of many decorators. And you can change them, or you could just decide which one to use. Maybe the watermark is different based on whether it's programming with intent or it's design patterns or whatever the thing may be. Right. So once again, we have instances of a thumbnailer base. We need a decorator that has the same ancestor, thumbnailer base, so media thumbnailer base. Our decorator needs to descend from that same ancestry, and then over here, because it has an instance of it, we can give it in its constructor an instance of a media thumbnailer, whatever that is. They're all descendants from the same hierarchy. Right? So I have a media thumbnailer decorator watermark that descends from thumbnailer base. It also implements the iDisposable interface only because it has a bitmap that it needs to be disposing. I'm just sort of making this more real. I'm using a bitmap internally, which is that watermark image, and eventually when you close out an application, you must dispose it. I'm not doing the disposing, but I just happen to implement it. And it's got some logic here to I guess, superimpose the watermark on top of the image that's been given at a specific location with a margin of 10. So it's 10 pixels from the boundary, left boundary, and the bottom boundary. So we should see that watermark appear on the left bottom with a margin of 10. So that's just logic. You can look at this logic on my GitHub when I post the project over there. But it's a decorator, and it descends from the media thumbnailer base, right? So go back to the context. Okay. So we can do the same thing here. What we need is really a, oh, look at that. I already have the decorator in place. Did I just do that? Oh, this is for the wrong, this is the sorting. Yeah. Got a bit confused. Thumbnailer context. Okay, so here, now we need to do the same thing that we did in the sorting. We'll say we're going to create a new, what is called Watermark Decorator. And it needs an instance of the thumbnailer, so we'll give it that instance of the thumbnailer, and then it can call the generate thumbnail, providing it with all the information. So remember, the signatures are the same, so they need the same information, but it's not using the information itself. It's saying, okay, you thumbnailer, you go to the thumbnailing, and once you're done, I'll slap on the watermark on the top of that. Right? So now if you were to run this application, audio, hey, look at that. You got now the same image from the audio that was thumbnailed, in this case, has the watermark in the left bottom with the margin. And if you want, we can, let's just to play a little bit, let's just change the margins a little bit. So let's say I made this, 30, right? Then you'll see this shifted quite a bit deeper into the application. And if I use the video, see, the decorator doesn't care what it is. As long as it's an image, it'll let the actual thing do its part by calling it internally, and then it'll do its part. On top of that, it'll decorate a pre-existing, completely self-sufficient functionality. It simply decorates. And then that's that. And if you look at our image thumbnailer, it decorates that too. Right? So this is not like, it's not like a visual thing where I'm putting this on the top of the form. This is actually part of the image itself, since we're doing that for all this stuff. And so moving this margin back to 10, you can see that all of these images are being decorated. All of the outputs of each of the thumbnails is being decorated by the decorator. So I'm hoping this has been a useful example of the decorator. I was trying hard to I was trying to make this more real worldish rather than this, unfortunately unhelpful, I think, toy examples of coffee and games. And I've seen all kinds of, things that people, unfortunately, those examples are so simple, and as a result, in some cases, even the person talking about the example is confused about what the decorator is, or is misusing the decorator to do the actual work. And so I thought maybe providing a real world example will give you a much better idea of when to and when not to use the decorator. So if you've enjoyed this video, please give me a thumbs up. Have any comments or questions, please put them in the comments, and I will see you next time.